This video is meant to show you how to work with vectors, something called vector addition. And in the unit we're currently in, of course, we're looking at two-dimensional forces and two-dimensional motion. And so we'll be looking at force vectors and displacement vectors. But it doesn't really matter what kind of vector it is. We handle them the same way. What you're going to learn today is the math functions you need are sine and cosine, inverse tangent, and Pythagorean theorem. And with those four tools, you can resolve or solve for any vector addition. So this little program we've got over here is a wonderful program from the PhET simulations. We haven't used any of those yet, but we will be. And so I'm just making a vector. And so I'm going to grab a vector here, stretch it out. Of course, this is a vector because it has a size and a direction. Now up here, this little window here, you're going to always keep an eye on this. This basically shows us the two ways to describe a vector. A vector either can be talked about in terms of its total length, which in this case is 20. And if you notice, there are 20 blanks. Every big box is 5, so it's easy to keep track. And its angle is 0, because we will take along the x-axis to be 0 degrees. Well, that's one way. You can give me the length and the angle, and those are called the polar coordinates. Or you could give me the individual x and y components. These are called the rectangular coordinates, and in this case, it's 20x and 0y, which if you look at that, that's obvious why it's called that. Let me grab another vector. And right now I'm putting both on the origin, starting both at the origin. And this vector is 15 long, at an angle of 90 degrees because it's straight up the y-axis. Rectangular coordinates are 0x and 15y. All right, we don't know what these vectors are, but let's suppose, for example, they're force vectors. And so some object is experiencing two forces. One force 15 at 90 degrees, the other force was 20 at 0 degrees. Well, what would be the net force, or the overall force? We call that the resultant force. Well, in order to do that, we need to add these two vectors together. And adding vectors is not the same as adding scalars. And adding scalars is simple. 2 plus 2 is 4. 4 plus 3 is 7. It's real simple. And the minus sign means, of course, just to subtract. Here, with vectors, it's not that way. Not that simple. We have to also take into account the direction. Well, the classic way to add vectors is what we call head-to-tail addition. You notice each of these arrows has a head and a tail. This is the head and that is the tail. And so to add vectors, we take the head of one vector and attach it to the tail of a second vector. So that's what's happening right here. And so I have added these two vectors. I've added vector 1 plus vector 2. But what is the answer? Well, the answer, let's say show some here. Here is the answer. The answer is this green arrow. Now this green arrow, you notice, says it's 25 long and at an angle of 36.9 degrees, which would be this angle in here, common to the x-axis. It also tells me that it has an x of 20 and a y of 15, which if you look, you can obviously see that. It goes over 20 and comes up 15. This is called the resultant. Now, I just want to start with this very simple right triangle to make sure you understand a little bit how to add vectors on the calculators. That's why I have a calculator over here. This program is giving you both of these simultaneously, but what if you didn't know this part? What if you didn't know it was 25 and 36.9? How do you get that? Well, we do know that these two vectors, they're 20 to the right and 15 up. And so the sum of this is the Pythagorean theorem. So if I turn on my calculator and if I use the Pythagorean theorem, that would be the square root of 20 squared plus 15 squared. And there's my resultant of 25. Now, how do I get this angle of 36.9? Well, I know the opposite side is 15 and the adjacent side is 20. Opposite and adjacent is a tangent function, but I'm looking for the angle this time. I'm not looking for the tangent of the angle. I'm actually looking for the angle itself. So this is for, how we use inverse tangent. So I'm going to go second tan. You see that tan negative 1. And I'm going to take the opposite edge, which was 15, and divide it by the adjacent edge, which was 20. and I get 36.9. Here's a reminder, by the way, make sure when you're doing this that you are in degree mode. If you're in radian mode, you get a completely different answer. All right, so to quickly review that, to find the resultant of these two vectors being added together, since I knew these two vectors, I simply took the Pythagorean theorem to figure out the overall result and inverse tangent to figure out the angle common to the x-axis. All right, let's try something a little more involved. Let's grab another vector, and this time let's say this vector is, well, it's 18 long at an angle of 33.7, or we could say it's 15 along the x and 10 along the y, up the y. And here's another vector, and let's say this vector is 10x but negative 5 along the y. The resultant would end up being this. So I'm going to hold this out here for a minute. So let's figure out how long is this and what angle is this? Well, here's how we do it. We come back to this one. 15 on the x, 10 on the y. So let's just focus on the x for a minute. 15 on the x for this one, 10 on the x for this one. So the resultant would be 25 along the x. For the y, this one is 10 up, but this one is 5 down. So I've got 10 minus 5. So we know that the resultant is actually 25 to the right, 5 up. And no surprise, if I look here, that's exactly what I end up doing. I get 25 to the right and 5 up. But how long is this? Now this tells me it's 25 and a half, but let's verify that. So that would be Pythagorean theorem. Second, 25 squared plus 5 squared. And there's my 25 and a half with a little rounding. And then to get this angle, remember we said that this is 5 and this is 25, so it would be the inverse tan of 5 divided by 25, and there's 11.3. Okay, now what if we had a third vector? Let's add a third vector here. Now if you have a third vector, you still just do head to tail addition. It's always the head of one attached to the tail of the next one. So I'm going to make this one, this third vector, quite a long vector. In fact, let's look at it. This vector is, well, it's 10 to the left, so that's negative 10, and 25 up. Okay, and if I use Pythagorean theorem between these two, I'd get 26.9. This is a good chance to show you something, though. In doing Pythagorean theorem, just disregard that negative sign, because your calculator, orders of operation, if you put the negative sign in, you're going to have trouble. Let me show you what I mean by that. If you take we all know that the negative 2 squared is 4, but watch what happens if I actually try to do that on my calculator. Negative 2 squared, and I hit enter. Oops, I get negative 4. What's going on? Well, the orders of operation, it squares the 2 and gets 4 and then takes the negative of it. That's not what you meant. So you could either do something like this. That would work. But quite frankly, the simplest thing to do in Pythagorean theorem is just don't use the negative sign at all. So to get this value of 26.9, they simply took the square root of 25 squared plus 10 squared, and that gives you 26.9. And then if you do the inverse tangent of 25 over 10, or negative 10, well, let's try that. What happens when you do that? If you take second tan of 25 divided by negative 10, you get negative 68.2 degrees. Negative 68.2 degrees. Well, what does that mean? What does that negative angle mean? Well, first of all, if you come back up here and realize this particular vector is in the second quadrant. It's got a negative x value but a positive y value, and it says it's negative 68. Well, if we had a protractor and we measured this angle right here, this angle from the x-axis, it would be negative 68. Measuring, if you measure clockwise. Well, in other words, it's 68.1 or 0.2 away from 180. In fact, if you take 180 and subtract 68.2, you get 111.8, which is exactly what it says the angle is. So one of the things that we'll deal with, and we'll probably do this in class more because it'll be a little bit easier for me to help you with that, is how to handle angles bigger than 90 degrees. But when you're in the second quadrant or the third quadrant or the fourth quadrant, your angles will be bigger than 90 degrees. Now the overall resultant, it tells me, is this angle here. 33.5 at an angle of 63.4. Well, if you break it down, each individual vector had an x. We had 15 plus 10 plus negative 10. All right, so the resultant x was 15, which we can see here, but I want to look at it from the vector perspective. This grid is nice, but you won't have that on your own paper. In terms of the y, we have 10, and then we had minus 5, and then we had 25. So, according to this, our resultant has an x of 15 and a y of 30. All right, so to find the resultant, let's take the Pythagorean theorem of 15 squared plus 30 squared, 33.5, and second tan of the opposite, which was 30, divided by the adjacent, which is 15, and there's my 63.4 degrees. So as we go through vector addition, you're going to find out it's all going to be about either sine and cosine, and that's what you use to figure out the x and y components if you have the hypotenuse and angle, or we'll use Pythagorean theorem and inverse tangent to find the resultant polar coordinates if you know the x and y components. So all vectors, no matter what they are, whether they're displacement vectors, force vectors, acceleration vectors, velocity vectors, for example, they're all handled the same way. There's not different rules for different kind of vectors. All vectors follow these mathematical rules.